Good afternoon, dear conference participant. The aim of the work was a mathematical and computer modeling to assess accuracy and adequacy in torque measurement. In this paper, a mathematical and computer modeling approach is considered to assess the accuracy and adequacy of torque measurement by strain gauge dynamometer. Computer modeling allows predicting the performance of a strain gauge dynamometer and simulating it under various mechanical and physical data. Strain gauging is based on the phenomenon of the strain effect, which is a change in the active resistance of the conductor of the primary transducer strain gauge under the influence of mechanical stress and strains. The use of strain gauge is scientific and technical research allow monitoring the formation of stress under static and dynamic loads. The main task of this work is to develop and control the torque of the motor shaft and to assess the adequacy of the mathematical model and the degree of accuracy of the results obtained using the developed model of the experimental data or test problem. The main objective of this work is to develop a torque control unit that can be built into exciting standard equipment during its modernization or repair. Testing of various types of engines and power generation equipment to improve design, increase operational reliability, reduce thermal, mechanical, electrical, and other losses, and increase efficiency requires creation of more advanced measuring equipment to determine the torques transmitted by the rotating shaft. The use of torque measurement equipment, which is caused by the need to determine the power of power equipment, as well as conduct operational and resource test of mobile power units, engines of tractor, agriculture, machinery, and other vehicles. To determine the load resistance force in a mechanism with a rotating output shaft and similar tasks and problems. The application for torque measurement device are quite diverse, as are the requirements of them. Therefore, there's many torque measurement systems available. The classification of device for measuring torque is based on various features: purpose, design features, operating principle, operating condition, accuracy of the information obtained, etc. The most convenient for use is the classification of torque measurement by the principle of operation, according to which all instruments and devices for measuring torque can be divided into mechanical brakes, electric brakes, aerodynamic brakes with differential mechanism, inductor brakes, drive motors. And now we can see a prototype of torque measuring unit. The strain gauge works as follows. The torque from the machine drive is transmitted by means of a V-belt or chain to the drive parts, a pulley or sprocket on the body 1, from it to the elastic element 5, and then to the hub 3, and then throw the keyway of the shaft on which the strain gauge is mounted. The deformation of elastic element is perceived by strain gauge 6. The electric current of the unbalance of the strain gauge C-cut is transmitted through the conductor lead along the road 9 to the measuring equipment through the current collector. The use of an elastic element in the strain gauge in the form of a hollow cylinder with a wall thickness selected from the radio. Where DC is, and we can see a formula where DC is a diameter of the annular cross-section of elastic element along the center line, allows to create on its surface by varying the geometric dimensions of the annular cross-section of elastic element, the maximum level of tangential stresses equivalent to the measured torque, and at the same time a significant value of the torsional stiffness of the elastic element, which provides a high natural frequency of the strain gauge to increase the measurement accuracy. And we can see an inverse characteristic for assessing the effect of resistance change in the bridge arm on the unbalanced voltage. It's top graph. An inverse characteristic for assessing the effect of temperature change on resistance change in the bridge arm. It's middle graph, and depends of measured resistance on unbalanced voltage. It's bottom graph. On this page, we can see dependence of the measured resistance on the unbalanced voltage and resistance in the arm of the balanced bridge, full calibration characteristic. On the second figure, we can see sensitivity of the measuring unit to changes in the measured voltage and resistance in the arm of balanced bridge. And on the first figure, we can see measurement error as a function of unbalanced voltage and balanced resistance in the bridge arm. Sensitivity of the measuring unit. Sensitivity of the measured unit to change in the measured voltage and resistance in percentage of the balanced bridge arms. The adequacy of the model is understood as the degree to which the results obtained using the developed model correspond to the data of the experiment of test or test problem. The purpose of the adequacy test is to ensure that the accepted set of hypotheses is valid at the stage of the conceptual and mathematical model, establish that the accuracy of the results obtained corresponds to the accuracy specified in the term of reference. The reason for the inadequacy of the mathematical model may be as follows. The value of the specified model parameters do not correspond to the permissible range of these parameters. The accepted system of hypotheses is correct, but the constant parameters is the defining relation are not set accurately enough. The system of hypotheses used is incorrect. If the results are inadequate, the model should be adjusted considering the reason in the above sequence. Conclusion. Errors in measuring the strain gauge resistance are a component of the torque measurement error. Computer modeling allows to predict the performance of the strain gauge and simulate it under various mechanical and physical conditions. The obtained estimates allow us to track the influence of an external factor, such as temperature, and the accuracy of the system parameters, such as reference resistance in the arms of the measuring bridge. On the final results, the value of the measured torque. Thank you for your attention.